Let's evaluate the definite integral from 0 to 2 of 3x squared over x cubed plus 1 dx. Our first step, of course, is going to be finding the antiderivative, and notice that we're going to need a u substitution for that. I wanted to do this example to show you how to deal with the limits of integration when you're doing a u-sub. There's two methods, and I'm going to first show you my favorite method, and it's my favorite because it's more streamlined. So here goes. We're working on this definite integral. And the u-sub we need is to let u be x cubed plus 1, and then du will be 3x squared dx, because du dx would be 3x squared. Now, if we're going to use a different variable, that's going to affect the limits of integration. So when x is 0, that implies that u will be 0 cubed plus 1, which is 1. And when x is 2, that implies that u will be 2 cubed plus 1, which is 9. So putting that all in, we have our 3x squared dx will turn into du. And then our x cubed plus 1 is our u, and that's in the denominator. And our limits of integration change to being from 1 to 9. The antiderivative for 1 over u is ln of the absolute value of u, and we're evaluating that from 1 to 9. So we have the ln of 9 minus ln of 1. Now the ln of 1 is just a 0, so that leaves us ln of 9, which is our final answer. Here's the other method. So again, this is for the integral from 0 to 2 of 3x squared over x cubed plus 1 dx. And again, we're going to let the u be x cubed plus 1, which means that du will be 3x squared dx, because du dx is 3x squared. So once again, I'm going to wind up with 1 over u du. This time, though, I'm not going to change the limits of integration into u values, which means I'd better label these as x values. And that's important. You need to do this if you're going to use this method. The integral of 1 over u du is ln of the absolute value of u, and I'm integrating from x equals 0 to x equals 2. It's important to put the x's in and say x equals 0 and x equals 2, because otherwise you're saying that the u's will be 0 and 2, and that's not what we mean. What we'll do, though, is put in the expression that u is referring to. Let's see, u is referring to x cubed plus 1. So I have the ln of the absolute value of x cubed plus 1 going from 0 to 2. And now at this point, I don't really need to say x equals, because I see that x is the variable in my expression. So I'll have the ln of the absolute value of 2 cubed plus 1 minus ln of the absolute value of 0 cubed plus 1. So that gives me ln of the absolute value of 9, and the absolute value of 9 is just 9, minus ln of the absolute value of 1, and the absolute value of 1 is just 1. And again, the log of 1 is just 0, so I wind up with ln of 9.